imagine we have two polystyrene blocks, and we're going to push them so that they're only 1 nanometer apart. So essentially really touching. And then the question is, how much force will it take to pull them back apart once they're 1 nanometer apart? Well, to do this, we can see that the main phenomena here is Hamaker attraction. So we'll write down for us what Hamaker attraction is. The potential energy for two blocks is negative H11 12 pi over h squared. And now we can see H11 is appropriate to use when we have two materials, we have two blocks made of the same material, material 1, separated by nothing. So there's not going to be anything between them. Okay. And force, since the question asked about force and not potential energy, remember that force is the negative derivative of potential energy with respect to distance. So let's go ahead and take this derivative. So we've got the Hamaker constant 12 and pi are all constants. So we can pull those outside. Those will be unchanged. And the variable is h, so we've got h to the negative 2, so the derivative of that would be 2 times h to the negative 3. So we have h cubed on the bottom, and then we have a factor of 2 up here. Great. So let's simplify that just a little bit. We'll cancel the 2 with 12 to give us a 6. So we've got h11 over 6 pi h cubed. Okay, well, let's plug in our numbers here. So we have to look up the Hamaker constant for polystyrene, and it is 6.58 times 10 to the negative 20 joules. And the distance we said was 1 nanometer. So we've got 10 to the negative 9th meters. We're cubing that. So that gives us 3.5 times 10 to the 6th newtons per meter squared. Remember that the Hamaker equation for blocks gives the answer in terms of force or energy per unit area. So we have to figure out what the area is here. The area of each side is going to be a centimeter by a centimeter. So that's 10 to the negative 4th meters squared. So the force, it's really, we should label this as being force per unit area. But anyway, the overall force is going to be 3.5 times 10 to the 6 newtons per meter squared. And then we've got to multiply that by the actual area, which we said was 10 to the negative 4th meters squared. And so we can see the force is going to be 350 newtons. Now that is actually a pretty big force. That's equivalent to about 80 pounds. So think about this. If you tried to pull apart these little styrofoam blocks, really the size of a pair of dice, there'd be 80 pounds of force necessary to do so. And since Hamaker attraction is present in all objects, you might wonder why you're able to pick your mouse off your desk, or anything else when it's all held together by Hamaker attraction. And the answer is that most objects are not atomically flat. And so that means that even if we have these polystyrene cubes, then it look to us that the surfaces are very, very flat. In actuality, on a microscopic level, the surface might look something like this. There's huge disparities on the surface. And the same thing is true with the other block. And so what that means is that objects are held apart by these asperities on the surface. And so actuality, they're held quite far apart, much further apart than 1 nanometer in general. One case where this isn't true is when we start to look into nanotechnology. Things like graphene and carbon nanotubes are atomically flat, and that means they tend to stick to each other. And getting them not to is a real problem in nanotechnology. It's called the sticky fingers problem, in that when you start to move around things on this atomic level, and things actually have they're able to approach each other on the atomic level, they get stuck to each other by the Hamaker attraction.